Hello students, welcome to my channel Engineering Education. Please subscribe my channel. Thank you. This lecture is about introduction and basic concepts of thermodynamics from the book of Thermodynamics in Engineering Approach by Cengel and Boles. Objectives of this lecture are to identify the unique vocabulary associated with thermodynamics through the precise definition of basic concepts, to form a sound foundation for the development of the principles of thermodynamics. Second objective of this lecture is to review the metric system, international and English unit systems. Third is to explain the basic concepts of thermodynamics such as system, state, state postulate, process and cycle. Also to review concepts of temperature, temperature scales, pressure, absolute and gauge pressure. Moreover, to introduce a systematic problem solving technique. How we define thermodynamics? First of all, we must define thermodynamics. That what is thermodynamics? Thermodynamics is basically the science of energy. It can be defined like this: the science of heat, work and properties of system and their mutual relationship. There are many definitions of this, keeping in view various things. Thermodynamics can be defined in other ways as well. So what is energy? Energy is basically the ability of a body to do work, and it causes changes. The name thermodynamics stems from the Greek word which means heat and power. Therm means heat and dynamics mean power. Conservation of energy principle. During an interaction, energy can change from one form to another, but the total amount of energy remains constant. Other statement of this principle is energy cannot be created or destroyed. There are laws of thermodynamics: first law of thermodynamics, second law of thermodynamics. So what is first law of thermodynamics? An expression of the conservation of energy principle. The first law states that energy is a thermodynamic property. Other statement of first law of thermodynamics is heat and work are interconvertible. The second law of thermodynamics is it asserts that energy has quality as well as quantity, and actual processes occur in direction of decreasing quality of energy. There are branches of thermodynamics. One is called classical thermodynamics, second is called statistical thermodynamics. So what is classical thermodynamics? A macroscopic approach to the study of thermodynamics that doesn't require a knowledge of the behavior of individual particles. It provides a direct and easy way to the solution of engineering problems, and it is used in the text. Statistical thermodynamics is about the microscopic approach based on the average behavior of large groups of individual particles, and it is used in this text only if if it provides the supporting role. So mostly classical thermodynamics is mostly applicable in thermodynamics. Application areas of thermodynamics are refrigerator, boats, aircraft and spacecraft, power plants, The design of many engineering systems such as this solar hot water system involves thermodynamics for a home. All activities in nature involve some interaction between energy and matter. Thus, it is hard to imagine an area that doesn't relate the thermodynamics in some manner. Other application areas are human body, cars, wind turbines, food processing, and a piping network in an industrial facility. These are some units which are called 7 fundamental basic units in System International: length, mass, time, temperature, electric current, amount of light, amount of matter. Respective units are meter, kilogram, seconds, Kelvin, ampere, candela, mole. Sometimes in thermodynamics, or even in every problem solution, we need multiples, and they have given some name which is called prefix. For example, we have kilo, which is equal to 10 to the power 3. For example, we have milli, which is equal to 10 to the power minus 3. So this is multiple. These are multiples and submultiples, and they are denoted by prefixes. So prefixes are used with the units to represent a quantity, and they are applied in problem solution. Some other units which are derived units from the basic units, also called composite units, in which force has the unit of Newton, which is equal to kilogram meter per square second. Also work has the unit of Newton meter or joule. Dimensional homogeneity: all equation must be dimensionally homogeneous. Unity conversion ratios: all non-primary units, secondary units can be formed by combinations of primary units. As discussed earlier, force units, for example, can be expressed as Newton is equal to kilogram meter per square second. Unity conversion ratios are identically equal to 1 and are unitless, and thus such ratios or their inverses can be inserted conveniently into any calculation to properly convert units. Every term in an equation must have the same units. When we are solving problems, so unit consistency is very important to follow while solving a problem. Student must check the units in calculations. Some basic terms which are very important to discuss regarding thermodynamics are system, surrounding, boundary. System: a quantity of matter or region in space chosen for study is called system. Surroundings is the mass or region outside the system. Boundary is the real or imaginary surface that separates the system from its surroundings. The boundary of a system can be fixed or movable. System may be considered to be closed or open, also isolated. There are 3 types of systems basically: closed, open, and isolated system. So closed system has the control mass, a fixed amount of mass, and no mass can cross its boundary, while energy can cross boundary in closed system. This is the example of system, boundary, and surrounding. This is an example that mass can't cross the boundary of a closed system, but energy can. And this is an example of closed system with moving boundary. Here we have less volume, but here we have greater volume. 1 cubic meter and 1.5 cubic meter. Mass remains same, 2 kg. Open system is controlled volume system, a properly selected region in space. It usually encloses a device that involves mass flow such as compressor, turbine, nozzle. Both mass and energy can cross the boundary of the control volume. Control surface, the boundaries of a control volume, it can be real or imaginary. For example, these are the boundaries, imaginary boundary, and this is the fixed boundary. Below is the real boundary. So this is an example of open system in which mass and energy both are crossing the boundary of the system. Properties of a system. Property, any characteristic of a system. Some familiar properties are pressure, temperature, volume and mass. Properties are considered to be either intensive or extensive. There are two types of properties, extensive and intensive properties. Intensive properties are those that are independent of the mass of a system, such as temperature, pressure and density. Extensive properties are those whose values depend on the size or extent of the system. For example, total mass, total volume, total energy of the system, they are example of extensive properties. There are also some specific properties. When we take extensive properties per unit mass, they become specific properties. For example, specific volume, specific energy. Specific volume is basically volume per unit mass, and it has a unit of cubic meter per kilogram. Similarly, we have some other properties which is called density. Density is mass per unit volume, and it has a unit of kilogram per cubic meter. Specific volume is basically the reciprocal of density, and it is the volume per unit mass, having the units of cubic meter per kilogram. Some other properties are specific gravity and specific weight. What is specific gravity? The ratio of the density of a substance to the density of some standard substance at a specified temperature, usually water at 4 degrees C. So density of any substance divided by density of water, and it is called specific gravity, having no units. These are the values of specific gravities from some substance. For example, water has 1, blood is 1.05, and for bones it is 1.7 to 2. Specific weight is the weight of the unit volume of a substance, represented by gamma, and it is equal to rho g, where rho is the density of the fluid and g is the gravitational acceleration. It has the unit of Newton per cubic meter, because from the definition, weight per unit volume, and weight has a unit of Newton and volume has unit of cubic meter. State postulate. The number of properties required to fix the state of a system is given by the state postulate, and it is the state of a simple compressible system is completely specified by two independent intensive properties. To define the state of the fluid, we need two independent properties, intensive properties, to completely explore the state of the fluid or working fluid. Simple compressible system means if a system involves no electrical, magnetic, gravitational motion, and surface tension effects. Process. Any change that a system undergoes from one equilibrium state to another is called process. For example, we have state 1 and we have state 2. So this is the process from state 1 to state 2. This is property A and this is property B on x-axis. So in between the state, what is happening, that is actually the process, and this is the path of the process. To describe a process completely, one should specify the initial and final states as well as the path it follows and the interactions with the surroundings. Processes diagrams plotted by employing thermodynamic properties as coordinates are very useful in visualizing the processes in thermodynamics. Some common properties that are used as coordinates are temperature, pressure, volume, specific volume. So, for example, this is the PV diagram. Sometimes we have here temperature and here we have specific entropy, TS diagram. So, for example, we have this process, compression process from 1 to 2. So, this is state 1 before start of the compression initial state, and this is the final state of the piston. So, what's happening from state 1 to state 2? Compression. So this is the process, compression process, represented by PV diagram, which is also called thermodynamic property diagram. We can also show and plot this process on TS diagram or any thermodynamic property diagram. The prefix iso is often used to designate a process for which a particular property remains constant. For example, isothermal process, isobaric process, isochoric or isometric process. Isothermal means in that process in which temperature remains constant. Isobaric process means that process in which pressure remains constant during the process. Isochoric means or isometric means in which the volume remains constant. What is cycle? A process during which the initial and final states are identical. Actually, processes combine with each other and they make a cycle. For example, if we take an example of gas turbine power plant, which operates in a cyclic manner, we have isentropic compression of the compressor. After that, we have heat addition, then expansion in the turbine, and then heat rejection in the heat exchanger. So these all processes, all thermodynamic process happens in a cyclic manner, and it is called cycle or the operating cycle of the system. So again, series of processes plotted on PV, TS, TH diagrams is called a cycle for a specific system. Steady flow process. The term steady implies no change with time. The opposite of steady is unsteady. For example, we have here a system. These are the properties at some time, for example 1 p.m. and the properties remain same at 3 p.m. So there is no change during the passage of time from 1 to 3 p.m. There is no change in the properties. So this is an example of steady flow process. A large number of engineering devices operate for long periods of time under the same conditions, and they are classified as steady flow devices. Steady flow process is a process during which a fluid flows through a controlled volume steadily. Steady flow conditions can be closely approximated by devices that are intended for continuous operation, such as turbines, pumps, boilers, condensers, and heat exchangers or power plants or refrigeration systems. During a steady flow process, fluid properties within the control volume may change with position but not with time. So no change with respect to time. Temperature and zeroth law of thermodynamics. The statement of zeroth law of thermodynamics is if two bodies are in thermal equilibrium with a third body, they are also in thermal equilibrium with each other. By replacing the third body with a thermometer, the zeroth law can be restated as two bodies are in thermal equilibrium if both have the same temperature reading if they are not in contact. So here we have two bodies, 20 degrees C copper and iron 150 degrees C. So heat transfer will start from the copper to the iron until and unless thermal equilibrium occurs. Means the temperature of this copper will increase gradually with respect to time, and the temperature of the iron will drop with the passage of time, because we know that heat flows from high temperature body to low temperature body. So here we have 150 degrees C for iron, so heat will start flowing from 150 degrees C to 20 degrees C copper. So, and at 60 degrees centigrade, the bodies iron and copper, they are in thermal equilibrium. When they have same temperature, there will be no heat flow, and we will say that these are in thermal equilibrium. Temperature scales are Kelvin, Rankine, degree Fahrenheit and degree centigrade. There are four temperature scales: degree Fahrenheit, Rankine, degree centigrade and Kelvin. Sometimes we need to convert one value of temperature to another scale. For example, we need for calculation, for problem solution, we convert degree centigrade into Kelvin, similarly degree Fahrenheit to Rankine. So these scales are in application in thermodynamic related problems. Conversion formulas are, if we want to convert a temperature from degree C to Kelvin, we will add 273 with the value of degree centigrade. Similarly, if we want to convert the value in degree Fahrenheit to Rankine, we will add around about 460 to the value of the degree Fahrenheit to get the value in Rankine. Similarly, to get the value in Rankine, and we have Kelvin value, so we will multiply respectively the temperature and we will get the value in Rankine. So these are the conversion formulas. Pressure, another important term which is mostly used in thermodynamic studies. A normal force exerted by a fluid per unit area having the units of Pascal, which is equal to 1 Newton per square meter. F force has a unit of Newton and area has a unit of square meter. 1 bar is equal to 10 raised to the power 5 Pascal. Sometimes we need it to convert bar into Pascal while solving the problem. Similarly, 1 bar is also equal to 0.1 megapascal or 100 kilopascal. So there are various types of pressures, which is called absolute pressure, gauge pressure, vacuum pressure, atmospheric pressure. Absolute pressure is that pressure which is the actual pressure at a given position. It is measured relative to absolute, vacuum, absolute zero pressure. Basically, absolute pressure is the summation of gauge pressure and atmospheric pressure. Gauge pressure is basically the pressure of the device which is fitted on the system, that is the gauge pressure. So it can be calculated from the difference of absolute pressure and atmospheric pressure. Vacuum pressure, pressure below atmospheric pressure. So we can calculate it from the difference of atmospheric and absolute pressure. Variation of pressure with depth. There is variation in pressure with depth. This is the free surface of the fluid, and as we go down, the pressure rises, and this pressure rise is linked with P is equal to gamma H, where gamma is the specific weight of the fluid and H is the depth of height. If there is a room filled with a gas, the variation of pressure with height is negligible, because there is no change in density or no change in specific weight. While on other side, if we have some liquid at rest, so the pressure will increase while as we go down towards bottom. Pressure measurement devices. As for temperature measurement, we have some devices which are called thermometers. For pressure measurement, we have also some devices. One of them is called barometer. Barometer is basically used to measure the atmospheric pressure. Thus, the atmospheric pressure is often referred to as the barometric pressure. It is also called barometric pressure. Similarly, another device which is used to measure the small and moderate pressure differences is called manometer. A manometer contains one or more fluids such as mercury, water, or alcohol, or oil. And the expression used to measure the pressure is equal to summation of atmospheric pressure plus gamma H, where gamma is equal to rho g, where rho is the density of the fluid and g is the gravitational acceleration, and H is the respective height. Problem solving technique in thermodynamics. Normally in thermodynamics we solve problems, so some basic steps which must be followed are problem statement. First of all, there will be problem statement. Second, we have to draw the schematic. Third, assumption and approximation must be made. Fourth, there will be physical laws which will be applicable. Step 5, properties. Properties will be mentioned: pressure, volume. We have to note the values. Calculations. Once you identified the properties, processes, and made assumptions, then calculations are made. Once calculations completed, then after that they are interpreted and discussed, and suitable reasoning and justification is provided to verify the results. So that is step number 7. A step-by-step approach can greatly simplify problem solving, because this is step-by-step approach. This is an easy way to reach this destination, while this is the hard way, very hard way. The assumptions made during problem must be reasonable and justifiable. Also, the results obtained from an engineering analysis must be checked for reasonableness. when we get the values of the results, we should think that these are reasonable or not. Is it true or wrong? Neatness and organization are highly valued by employers. While solving the problem, we must take care about the neatness and about these steps, which are 7 steps, and we must follow these steps to solve a problem. Because an excellent word processing program doesn't make a person a good writer, it simply makes a good writer a more efficient writer. So while doing work with systematic way, it makes you efficient. So from problem solution, these 7 steps must be followed by a student. So summary of this today lecture is, we learned that about the thermodynamics and energy application areas of thermodynamics, SI units of quantities, system and control volumes, properties of system, density and specific gravity, state and equilibrium, processes and cycles, steady flow process, temperature and zeroth law of thermodynamics, pressure and its measurement, and problem solving technique. So this was all about the basics of thermodynamics, or introduction and basics of thermodynamics. Thanks for watching. Please like and comment on my videos. Also subscribe my channel to get new videos.